All right, these are your notes for Unit 5, assignment number 1. Okay. What is a parabola? So a parabola is a U-shaped graph that is generated from a quadratic equation. So there's some definitions here that are going on here. We have a parabola. You need to know what that means. It is a U-shaped graph. Okay, and it is generated from a quadratic equation, and you need to know what a quadratic equation means. So a quadratic equation, as you can see, is any equation where the largest exponent is a 2. Okay, so let me give you a couple examples over here of parabolas so you get an idea of what I mean by a U-shaped graph if you are concerned or confused at all about it. So let's say I have x and a y-axis here. And if I get a graph that is more or less shaped in the general description of what you would think of a U as, then that would be a parabola, okay? So that right there, that blue graph right there, is what is known as a parabola. It is not a V-shaped graph. It is a U-shaped graph. So it's a nice, smooth curve that if, like, I started over here on this left point right here, S, and I started on that point there, and I followed the graph around, you could see that I would be traveling in a downwards manner, and then I would hit a certain point right here where I would take a turn, and then I would be traveling on an upwards manner up until, say, I got to point E over here. Okay, you guys? So that's what we mean by a parabola. Now, an interesting point about a parabola is that parabolas are always U-shaped graphs, okay? But they will always only go in one of two directions. They will either be going in an upwards manner, like the parabola that I just showed you right here in example A, or they will be going in a downwards manner, like maybe this parabola right here, which I'm showing you in example B. Okay, parabolas will never go sideways, all right? So they'll either be like a U, some people refer to this as a smiley face, and you could see why, or they'll be in a U going down, which is some people refer to that as a frown, all right? So we have that right there. Now, quadratic equations are equations that generate parabolas, okay? And a quadratic equation is any equation where the largest exponent is a 2. So let me give you 3 examples of equations that would be considered quadratic equations. Here's the most basic quadratic equation that you could have. Y is equal to x squared. Notice the largest exponent in that equation is 2, okay? And it doesn't matter what any of the other numbers are. So for instance, it doesn't matter if you have a coefficient in front of the x squared. So say if I had y is equal to 7x squared, the coefficient is 2. That doesn't affect the fact that it's a quadratic equation. As long as the largest exponent is a 2 there, then we have a quadratic equation. All right, here's a more detailed quadratic equation here. This would be the third example, which would be, say, y is equal to negative 5x squared plus 9x minus 8. Okay, you guys, so notice even in this third example here, even though I have a negative 5, I have a plus 9x, I have a negative 8 here. If the largest exponent is a 2, then it is what's known as a quadratic equation. Quadratic equations always graph to make parabolas, okay? And you're going to learn about certain key vocabulary words associated with parabolas. Okay, so let's go over some of the key vocabulary words that you need to be familiar with that you're going to be hearing and using rather frequently in this unit here. Okay, so first of all, we're talking about parabolas. Remember, a parabola is a U-shaped graph, and like I just said, just like a minute or two ago, when you graph a parabola, you are going to get a U-shaped graph, and it's never going to go sideways. It's either always going to be going up or it's always going to be going down. Okay, so we could have a parabola that looks like this, and the parabola could be moved anywhere on the graph, or we could have a parabola that could possibly look like that right there. Okay, now the direction of the opening is a term that we use. So this first example right here, which we'll call example 1, this has an opening of an upwards opening. Okay, so this parabola is what we call an upwards opening. And the reason why it's called an upwards opening is because it is going up, as indicated by the arrows. In example 2 here, this would be a parabola with a downwards opening. Okay, and the reason why it is called having a downwards opening is because if you look at the arrows are pointing down. All right, so we have parabolas. They will have an upwards opening or they will have a downwards opening, always. They will never have a sideways or a right or a left opening. So we have an upwards opening, we have a downwards opening of a parabola. Okay, now, the line of symmetry is what this line is, and I'm going to give you a definition for it. So the line of symmetry is a vertical line. Let me type this in here for you guys, and you can pause it if I'm going too fast. So it's going to be a vertical line going through the vertex that divides / splits a parabola into 2 equal parts. Okay? So when we talk about a line of symmetry is going to be a vertical line. It is, it goes through the vertex, and we'll talk about what a vertex is in a second, and then it divides or it splits the parabola into 2 equal parts. All right? Pretty simple when you look at a parabola and to tell where the line of symmetry is. So let's say that I have a parabola here, and I'll give you 2 examples of the parabolas, okay? One example will be a parabola with an upwards opening, and one example will be a parabola with a down. Okay, so the first parabola would be a parabola with an upwards opening, okay? Like this right here. All right, there's an example. Okay, now I'm just sketching them, so these are not great sketches of what these parabolas actually will look like. Remember, they are perfectly U-shaped graphs right here. Okay, but if you notice right here in this parabola, the first one right here, example number 1, the one that has an upwards opening, at some point in time, if I started over here on the left of the parabola, say at point A, and I just followed the parabola around, at some point I bottom out at that parabola and I reach the lowest point of the parabola. Okay, and then, so if I started at point A, I'm traveling down on the parabola, but when I hit the lowest point, from then on, I'm traveling up the parabola. Okay, and the same goes for the example number 2 here, the parabola that is a downwards opening. If I started at point A on the parabola and I traveled along the parabola, you can see that I'm traveling up the parabola, but at some point I hit a point where I get to the highest point of the parabola, and after that point I'm now traveling down the parabola. Okay, now the line, the vertical line that goes right through that point. Okay, so this vertical line, which I'm drawing in as a dashed line, that line is what is known as the line of symmetry. So what that line of symmetry does is it divides or it splits the parabola into 2 equal parts. If I jump over here to example number 2, the line of symmetry would be this vertical line right here that divides the parabola into 2 parts, okay? So whenever you denote a line of symmetry in a graph, you do it using, you'll notice when you look at your math book, you denote a line of symmetry as a dashed line, and it's always going to be a vertical line. Okay, now if you notice in the definition, it says that it's a vertical line going through the vertex. Okay, and that leads us to our last important point or important definition or key vocabulary of a parabola is the vertex, and the vertex is the lowest or highest point on a parabola. Okay, so another key vocabulary word is the vertex, and you have to know what we mean by when we say vertex, and you also are going to be responsible for recognizing a vertex when you see a vertex in a graph. Okay, so the vertex is always going to be the lowest or the highest point on a parabola. So going up here to my graphs right here, in example number 1, that point right there where that arrow is pointing, that is going to be the vertex of that parabola, okay? There is no other point that gets lower than that point right there. In example number 2, the point right here, which is the highest point of the parabola, that point right there would be the vertex, okay? And one thing that you'll need to remember is that the vertex is always on the line of symmetry, or the line of symmetry always goes through the vertex, always, okay? So the vertex of a parabola is going to be the lowest point if the parabola is opening upwards, or it's going to be the highest point if the parabola is opening downwards, okay? So there's some key definitions or key vocabulary words for you for parabolas. Now, let's just go over how to solve some equations, okay? So let's go over how to solve equations with x squareds in them, and then let's go over how to solve equations with square roots symbols in the equation. So I got 3 examples of each. So the first example here, you can see we have x squared is equal to 9, okay? Now, if you ever want to solve an equation for x, if there's an x squared, the way that you eliminate an x squared is you take the square root of both sides of the equation, okay? And the reason why you do that is because the square root symbol cancels out the exponent of 2. So you could see that because the square root symbol canceled out the exponent of 2, we are left with x is equal to the square root of 9, and then you just figure out what the square root of 9 is. So the square root of 9 is equal to positive 3, whoops, sorry about that, guys, positive 3, or it is equal to negative 3. Okay, you guys, so that would be what x would be, positive 3 or negative 3. Now, example number 2, if you are solving an equation with an x squared, but there's another value involved, like plus 6, the first thing you always want to do is you want to isolate the x squared part. So anything that is not the x or the second power, you have to move to the other side of the equation. So in this example, I would subtract 6 from both sides of the equation, canceling out the 6's. So that would now give me the equation x squared is equal to 25. And then to solve this equation out, to eliminate an x squared, you take the square root of both sides of the equation. Okay, and the reason why, once again, is because the square root symbol cancels out the exponent of 2, and this would leave me with x is equal to the square root of 25. And because 5 times 5 is 25, that means x is equal to positive 5. However, negative 5 times negative 5 is also 25, so x is also equal to negative 5. Okay, you got to say both of the answers there when you're taking the square root. So we have x is equal to positive 5 or negative 5. Okay, example number 3, if you have a coefficient, in other words, a number in front of the x squared part, remember you have to get the x squared part to solve for an equation with x squared in it. You have to get it all by itself. So what you do is you, in this case, you would divide both sides of the equation by 4. All right, now you can see when I do that, what that does is that cancels out the 4's, leaving me with the equation x squared is equal to 16, and then I would take the square root of both sides of the equation. The square root symbol cancels out the exponent of 2, and this would leave me with the equation x is equal to the square root of 16. Okay, now because 4 times 4 is 16, that means x is equal to positive 4. However, negative 4 times negative 4 is also 16, so x is equal to negative 4 as well. You've got to put both answers down. Okay, moving over to examples 4, 5, and 6, where we're solving equations when we have a square root symbol in it. So what you're going to do in this is you're going to kind of do the opposite of what we did in the previous 3 examples. We want to solve for x, so we need to get rid of that square root symbol. So to get rid of a square root symbol, what you do is you are going to second power or square both sides of the equation. And the reason why you do that is because, once again, the square root symbol cancels out the second power. And you can see when I do that, I'm left with x is equal to 49. 7 to the second power is 49. Okay, a little bit easier than the examples when you have an x squared in it. All right, now, number 5, if you have the square root of x minus 8 is equal to negative 3, before you do the second power of each side, you have to isolate the square root of x portion of the equation first. So in this example right here, I would add 8 to both sides of the equation. And what that would do is that would cancel out those 8's. That would isolate my square root of x. And then it would be equal to no longer negative 3. It would be equal to positive 5. Now, what I do at this point is that to eliminate the square root symbol, I have to raise both sides of the equation to the second power. All right, and once again, the reason why I do that is because the square root symbol cancels out the second power. That would leave me with just x is equal to 5 to the second power is 25. Last example, if you have a coefficient like the 3 in front of the square root of x portion of the equation, you would have to divide by 3 to get the square root of x isolated, okay? That would give me, at this point, create the new equation, which would be the square root of x is equal to 8. And then I need to eliminate the square root of the square root symbol. And the way I eliminate a square root symbol is I raise both sides of the equation to the second power. The square root symbol cancels out the second power symbol, leaving me with x is equal to, and then I would have 8 to the second power, which is 64. Okay, there we go. Notes assignment number 1, unit 5.